channel. So today we're going to be doing tables and values, and hopefully diving into how you can find the rules using the tables and values. So today's learning intention is to understand that a rule connects two variables. So two variables could include, x and y, which we see quite a lot in linear equations. You could do, cost per liters if we were looking at like petrol, which could easily be identified as C and L. It just really depends on the question. So today's success criteria, which you should be writing this down. I can complete the input and output table, which is what we will be primarily focused on in this YouTube video. You need to be able to find the rule from the table, which will be given to you using input and output values. And you need to be able to solve for values using substitution into a rule. So you'll get a rule, it could be like y equals 2x plus c, for example, plus 3. Okay, and you might get given, I'm just going to make that nicer. You might get given a value of x, so like x equals 1, and you might have to substitute x equals 1 into that rule, for example, so 2, 1 plus 3. Okay, so 2 times 1 is 2 plus 3, so y equals 5. Okay, so that's just an example, but today we're focused on input and output tables, which I will further explain to you. So just a few vocabulary before we get started. So a rule shows the relation between two variables. So for example, y equals output equals input plus 3. You've got other rules that you use for other topics, y equals mx plus c. You've got, your Pythagoras formula, c squared equals a squared plus b squared. You've got area formulas that you use in measurement. There's so many rules and formulas that you use in math. So input can also be called a domain, and output can also be called a range. And that's just something you can keep in the back of your mind. So for those of you who don't know what a table of values are, it's used to create a rule, and with this rule you can determine future values, okay, which I will further discuss. So the first example we're going to go into is we have to complete each table with the given rule. So the first one has been given to you, that's the rule there for you. Output equals input plus 4. So if we were to do that, okay, so I'm going to put this as O and this is I, just so you can see, all right? So the output equals input plus 4, okay? So output equals, we put the 3 in the I for input, okay? So the output is 7. That's the first one for you, all right? And we can just work our way through substituting the values into it. It was quite similar to the other video that I did make about equivalent expressions. So if you haven't already watched that, you should. So I'm just substituting the input values into the rule for you, and I'm just using O and I instead of input and output. So for example, output equals input plus 4, which is the rule. The input for this one is 12, so 12 plus 4. So 12 plus 4 is 16, okay? And that one there, O equals I plus 4. O equals 20 plus 4, which equals 24, okay? And now we've got our table by using the rule and the input values, and that's all, okay? So you need to make sure you show all your working out. Should probably write that. If you forget, you really need to make a reminder on your workbook. I can't emphasize that enough. So here we have a output and input formula with multiplication sign. So we're going to do the same thing, OI. You're more than welcome to use it. I don't see why you can't use it at the moment. So that's the formula there. So O equals 8 times 1 minus 5. So 8 minus 5 equals 3. Okay, and we can just work all of that out just by substituting the value into, oh, that's not right, hang on, just been thrown off a bit. O equals 8 times 2 minus 5. O equals 8 times 2, which is 16, minus 5. O equals 11. Okay, and now we just do the next one, and I might just turn down my writing a bit smaller because it's quite large. So 8 times 5 is 40, minus 5, which equals 35. Okay, so you just simply need to substitute the value of the input into I. So we've got 8 times 7, because that's our input value. So 8 times 7 is 56. I was just thrown off by how I write my 5. Sometimes my 5s turn into S's. That was something my teacher used to say to me when I was in high school. So I'm trying to really make the effort of not making it look like an S. O equals 8 times I minus 5. So 8 times 10 minus 5. 8 times 10 is 80 minus 5, so that would equal 75. And so there we have our values. Now, you don't have to be doing like these arrows when you show your working out. You can just have your working out like down your paper, because this can get quite messy. I'm obviously just showing you this because it's in a video. All right, so now we need to find the rule of each of the table of values. So by looking at this rule, okay, so we know that it's always output equals something that has input somewhere in here. We just don't know what we're doing with the input. Now I can look here that the output, okay, so to get this value here, what am I doing to the input? All right, so when I look at that, I can say that the input is, okay, plus minus 5. That's what it is, input minus 5. So I could put in a value just to try it. So for example, if I put 10 in my input, 10 minus 5, does the output equal 5? Yes, it does. So this rule works for the first one. Now I could try the second one. So output equals input minus 5. So the input 11 minus 5. Does the output equal 6 when I put input as 11? Yes, it does. Okay, and you could just show your proof. And sometimes questions, they say, you know, show you're working out, show that this works, and this is a way that you could do that. So an input 12 minus 5, so output equals 12 minus 5, which is 7. So when my input is 12, does my output equal 7? Yes, it does. Okay, and you can try it with the other two as well. And then if it didn't work for these two, then we know that this rule here would not work. Okay. So the next one is find the rule for each. So we know that it's output equals something to do with input. We just don't know what. All right. So with my output, okay, so when the output, let's say, is so when the output is 12, what am I doing to my input to get to that? Okay, what am I doing to these numbers to get to that? And I can see that it's a multiply by 6. So we could say output, okay, equals input times 6. So when I put in the value 2, for example, times 6, my output would equal 12. And that's right. And if I was to do that one there, the last value, output equals input times 6. So when I put my input as 6, does my output equal 36? Yes, it does. And so sometimes when you have a table of value and a rule that you've you've discovered, the question might ask you to find, you know, what would the output be if the input was, let's say, 10. So if the input, so let's write that down. What would the output be if the input is 10? And all you would do is this here. I'll just do it in a different color so you can see. Input is 10 actually means input equals 10. And you can do this with other rules, which you'll later learn with linear equations and graphs. So the formula we've discovered is output equals input times 10, input times 6, sorry. So we would put input 10 times 6, which equals 60, and you would therefore say, actually I'm going to write it down here so you can see it. You'd write, therefore, when the input is 10, the output is 60. Okay? And that's what you would do. And that is all for today. Thank you so much for watching. And if you haven't already, catch up on the videos that you haven't watched, which will be on our playlist. And if you have any questions, feel free to ask your teacher. Thank you.